All right. Hello, everyone. Today I am going to be playing around with Ollama. Ollama is a way to run LLMs locally on your machine. And it's similar to Llama File, which I've used and blogged about in the past. But it's good that we have lots of options and they both have really cute logos. So today we're going to be playing with Ollama. So let's get started. Now, I already actually downloaded this because I played with it yesterday. So it's already downloaded. You can see this adorable llama up here. So now I've got an elephant, a llama, a whale, a bunch of silly icons that aren't animals that don't count. But I'm really liking the llama. So I'm happy about this. So in fact, while it's up there, it is running a server with the LLMs on it without me doing anything. So just the fact that it's up there means that it is running a LLM server locally. So I also already pulled the Llama tool model yesterday. So if you run this command, so I'll run this now. And if you, after you download, when you run this, the first thing it'll do is try to pull it if you don't have it yet. So it's probably, I imagine it's going to check now to see that it's already pulled. Okay, so it's already pulled. So we can already start chatting with it. So it'll be like, haiku about hungry cat that wants tuna. Here we go. It wrote a beautiful haiku. So it's already got llama tool pulled and I can run with it there. And you can see the list of models. And this is not everything that can be downloaded. You can actually download a bunch more. If you look through this library, there's a huge number. But these are the ones that they're highlighting on the page. So I've got Llama 2 now. It's got 7 billion parameters. It was a 4 GB download, and that's how I ran it. I definitely want to try Mistral next because I hear really good things about that one. And it says down here you should have at least 8 gig of RAMs available to run the 7 billion parameter models, 16 gigs to run the 13 billion parameter models, and 32 to run the 33 billion parameter models. And there's not even any of those on that list, but there must be some in the library over here. And if you look at my computer, this is my work computer. It's got 16 gigs of RAM. So I can run 13 billion parameter models. Llama 2 is only 7 billion, so everything's working well right now. All right, so we've got it running here. So this is fun if you just want a little, command line thing like give me a snack idea that has chocolate in it. Right. And that's kind of nifty to just have this running locally and, not be spending any money on it. Oh God. It must be keeping in mind conversation history because now we see how about some chocolate covered tuna bites? And that sounds absolutely disgusting. Like, isn't that disgusting? Oh gosh. All right, now it's giving me some more reasonable ideas. Okay, great. So you can see we can have this fun conversation and it even sees our history. So it's actually a full conversation. The next thing I want to do is actually stop running that and actually interact with the API. So they've got multiple endpoints. If we go down here, we can try this one here, the /API/generate, and we'll paste this in here. And what we get back is a streamed response. So this is similar to how to OpenAI streams, where you get about a token in each response. So you get the tokens as they come, and we also get some prompt usage at the end. So this is a streamed response. However, this is not the same kind of API as OpenAI. It's not the exact same interface. So what I'm really interested in is the OpenAI compatible endpoint. And they added that very recently. There's a blog post here where they talked about it, OpenAI compatibility, and they've got an example here. So this is meant to really mimic exactly the OpenAI endpoints so that we can use it in the same way and actually use the OpenAI SDK with it. So let's just try uh running this one, going to /chat/completions, which is what I use the most often. And here, this is a non-streamed response. So we get back this JSON here that looks very familiar. So it's got the content here. And yeah, so that looks like an OpenAI response. The next thing we can do is actually use the OpenAI SDK. First, I'm going to make sure I'm inside a Python environment. Okay, and then I go ahead and install the OpenAI SDK. This is a Python package. You can also use SDKs for OpenAI in Java or JavaScript or whatever language you use. I usually use Python these days. So here they have an example. Now I've already modified this one to be more to my liking. Oh, I got really fancy with this. All right. Let's pretend that wasn't there. We'll make it a little simpler. Okay. Let's see if that looks like there. So we got the base URL, we got the API key. Now the base URL, that's pointing at that URL that we just hit up using that curl command locally. The API key, you got to give it some value, but it doesn't matter what it is. So just, put whatever you want in there. It just has to be a non-null value or non-none in Python land. And now here's the call to chat.completions, which is going to go to this endpoint. So we can see model equals llama 2. So temperature, let me raise this temperature back up. Max tokens, 100's fine for a haiku. N equals 1, so we're just getting one response. And here I have my system prompt says, you're a helpful assistant that makes lots of cat references and uses emojis. And then the user says, please write a haiku about a hungry cat wanting tuna. And then we print out the response. So let's try that out. And it is going to llama. There we go. So we have a haiku with emojis in it. And it's counting each emoji as a syllable, I think. So we've got cat, milk, hungry paws, tuna, dreams, fill, feline, mind, cat. I don't think this exactly follows a haiku structure, but I'm not an expert. So as we can see, we can use the OpenAI SDK with Ollama locally, which is very, very cool. It works for the chat completions endpoint. It does not work for all the other endpoints yet. Like it doesn't work for embeddings, notably. I have filed a request to add support for embeddings. So if you are interested in an embedding endpoint as well, let's see, where's my request here? Embeddings. And Pamela, there we go. All right, so it's number 2416. Yeah, so if you're interested in embeddings, star that, thumbs up, whatever, subscribe, whatever you want to do. But we can use chat completion, so we can get pretty far with it. So the next thing I want to do is that I have all these, sample chat applications built around OpenAI, like these ones here. So I want to see, can I substitute Azure OpenAI with my Ollama server and just have these apps still work? So let's start with the simpler one, which is just a really simple chat application with a front end and a Python backend. So I've got that running here, and let me make everything a little bit bigger. Okay, and open this up. All right, and then I put my thing here. So haiku about salmon this time, and this time I don't think it's a cat. There we go. So now it's it's actually really nice. Oh, but here's a question: is this good? This is actually currently probably going against Azure OpenAI. So this is actually GPT 3.5. So silent in river, salmon leap against the stream, nature's perseverance. Beautiful. So that was actually going against Azure OpenAI, and we get a pretty good response from that. And we can see because I've actually got debugging on. So where did I set my debugging? Logging. I must have set into debug mode because I can see the debug request. So if you're ever trying to debug your OpenAI SDK, just set the logging level to debug of your Python level, and then you'll be able to see the requests that go out. So I can actually see that it's making a post request to my Azure OpenAI account to the chat completions endpoint. And so that's where it's going. So that's how it looks with Azure OpenAI. So now let's go ahead and try setting this to pointing this at our Ollama server. So let's look at this. This is where we configure the OpenAI client. And I actually have lots of different forms of authentication, right? So it's, do you want to use a local endpoint? This is the path here. And this is one where I already set it up to work with Llama file. So in theory, this should be really easy to set it up to work with Ollama because they both have the same idea where they've got a local endpoint that is mimicking an OpenAI endpoint. So what we can see here is that it sets the API key to no key required. So that's good. And then the base URL, it sets to this environment URL, local OpenAI endpoint. So I'm going to go into my environment file here, my .env, and then set that equal to here we go, to this path. Now, this path is very similar to what I just used, but it's a little different, right? So this is what I was using here, localhost 11434/v1. Here, I'm using host.docker.internal 11434. And the reason for this is because I'm actually running my my app inside a Docker container, inside of specifically, I'm running it inside a VS Code dev container. You can tell down here it says it's in a dev container. I generally do all my development inside VS Code dev containers because it's my favorite way of isolating environments. But when I'm doing that, if I'm trying to reach from inside this container to something that's on my actual machine's network localhost, then I have to use host.docker.internal. So that's why that's host.docker.internal. That's going to reach the local host of my actual host machine. So it's going to reach outside this container. Or okay, so that's set there. So that should be good. There's one other change that we do need to make is the model. Because remember here, we look at this, it sets model equals llama 2. And down here, we have model is equal to Azure OpenAI ChatGPT deployment. All right, so I need to set this to Llama 2. So I'm just going to go ahead and add equals Llama 2 at the bottom here. And that should be everything I need to customize. Let's try it out and see if that works. All right, so we are running haiku about salmon. Let me go a little bigger. And we're going to look at the request. All right, what we can see is that it is indeed making a request to host.docker.internal to /chat/completion. So that all looks really promising. And here we go. We got a haiku about salmon. So it's interesting to see how that differs from the Azure one. So here, it actually decided to say sure. So I wonder if this Llama 2 is even more geared towards conversation where it feels the need to, say sure. And here's a haiku about salmon versus the Azure one just gave us just the haiku. So that's interesting just to, see little differences between the two models. And now let's try more emoji, a emoji filled haiku about hungry salmon. There we go. Beautiful. All right, so we've got it working inside a simple chat application. So we were able to swap OpenAI with the Ollama Llama 2 pretty easily. Now let's try the harder thing. And this is something I tried yesterday and failed, but I think I can do it today. We'll find out. So what I want to do is use it inside a RAG chat application. So let me show you what I'm talking about. This is the RAG chat application. So this is something where we can chat over documents. So we're actually searching Azure AI search to get back documents, and then we're passing those document chunks to ChatGPT when we want an answer, right? So I can click on this just to show you how it's working with its default setup with Azure OpenAI. And both of these are open source, by the way. So if you want the one I just showed, that is this repo here. I'll post that in the chat. And then the RAG one is this repo here. And since I'm doing links, let me go ahead and put all the other links in the chat that we were showing. Okay, so here we can see that the chat application is responding, and we can click the citation and see that PDF, and then we can go and look at the sources that got sent. So the goal is to point this app at to the local LM. All right, so let me give it a go. So here we are in the app. I will end the server for now and start doing some environment variables. So I try generally to configure everything with environment variables. So what I'm going to do is go down here and check to see what those environment variables are. So here you can see if OpenAI host equals local, because once again, I've already tested this with Llama file. So I already had some support for doing local. So we've got this OpenAI base URL. All right, so I'm going to set that. And this time I'm setting it a slightly different way because I'm using this AZD CLI for setting environment variables and doing everything. But let's set it to the same thing as before. So OpenAI base URL, it's going to be host.docker.internal because we're inside a container again. And, the port /v1. All right, and we'll just ignore that thing about AZD versions. And then we need to set the host, right? Because this is checking if it's only going to go there if OpenAI host is local. So I need to do OpenAI host local. All right. And then I also need to change the model. Remember, we need to change the model. So that's going to be this long variable name here. Okay, so now that should set all the environments. I can go ahead and check the environment I'm in, or which environment am I even in right now? Let's see. Up for demo. Okay, so yeah, we can actually see it here. So there's the OpenAI base URL. Here's the OpenAI host, and then up here is the ChatGPT model. All right, so that's a good start. Now there's more we need to do, but maybe I kind of want to show it like this so you can see the error that we run into next because I think it's interesting. So let me go ahead and run this in debug mode. All right, so we're starting up the server here. And we actually already got the error. So that was really fast. So the error is where do we go? We got to find the error amongst other things. It's in this file here. So it's in model helper. So let me see. Can we get to that from this call stack here? Model helper right here. There we go. All right. So here's the issue is that we have this model helper file that we use in order to calculate token limits because we're trying to, when we're doing this multi-turn conversation, we want to stuff as much information that fits inside the context window for the LLM. These are the context window limits. We don't want to stuff more that can fit. And the issue is that we've got this hard-coded list of LLMs to token limits, and we do not have Llama 2 on that list. So when it tries to look up the model in this dictionary, it can't find it. Now, this wasn't an issue with Llama file because Llama file just has you use the same model name and it ignores it. But Ollama has you specify the model name, and so this becomes an issue. Which is a good point because really we should care about the context window. So what I'm going to do is add Llama 2 here, and I looked it up earlier, and it's a token window, token limit of 4096 for the context window. So I'll add that there. And then there's also going to be an issue down here when it actually tries to use tick token to get an encoding to actually figure out the number of tokens, right? Because there's both, we have to know how many tokens we can fit, but also we have to then know, okay, here's our text that we think we want to fit. How many tokens does this encode into? Currently, we're using tick token for that. tick token is from OpenAI. So tick token does not have any support for these other models, so it cannot turn the text into tokens in these other models. Now, I did some research yesterday, and I did find a potential way to do the token counting for these models. This is from Simon Willison, who always is so good about documenting everything. So there's this tokenizer package, and what you can do is import tokenizer, create tokenizer from this pre-tained thing. So you have to download this file here, and then tokenizer.encode. So I'd have to map, all of the Ollama models to where they are on Hugging Face, and then you would download them when you needed them. So if I have time, I'm going to try that. For now, what am I going to do? I'm just going to fake it. So I'm just going to pretend that we are using the GPT-3.5 Turbo. So this is not a great approach, but since I don't have that whole tokenizers package, then this is what we're going to have to do. All right, so here we go. This should get us past this token counting phase, right? So we've got some accuracy in that we know how many tokens fit inside the Llama 2 context window, but we can't yet encode text into tokens. And hi, Jay. Jay inspired me to do more streaming. All right, so here we go. I'm going to run this. See if we get past that stage there. I'm going to open this up. All right, that looks promising so far. Fingers crossed. I did get this working at some point last night, but then I reverted all the changes so I could redo them in front of you. So let's see. All right, so we got a not found error. That's fine. Oh, this is expected. The issue here is that by default, we always use hybrid search for this app. Hybrid search is a combination of full text search and vector search. However, remember I was saying that Ollama doesn't yet have an embedding endpoint. So I'm going to have to do just full text search, which will still work pretty okay, especially for this query. But ideally we would, be able to do vector search and hybrid search. So that's why I'm, hoping that they add an embedding, OpenAI compatible embedding endpoint. All right, and then I'll turn off streaming just for more simplicity. Okay, so now I'll retry it, and this time it shouldn't try to hit up an embedding endpoint that just does not exist. All right, let's see. So here it went to the search index. So that's good. I'm just watching the network requests go by like you do. It looks like it did make a chat completion request to chat completions. That was successful. And so now it must be making this next chat completion request. So we actually use multiple chat completion requests as part of this flow. And I wrote a blog post about that today, in fact. So if you're interested in this, I talked about the way we use these multiple LLM requests as part of the RAG flow. So the first one's actually quite fast and the second one's slower. Okay, it worked. This is the Llama 2 model answering our questions in the RAG chat application. So it does actually work, which is cool. However, it doesn't work or at least it doesn't work the same way that our GPT models do. So big thing that I want to point out is that it's not paying attention to our prompt that says how to cite the sources. So let me show you. We have this thought process thing here, and here I can show you what actually happened, right? So what we do is we take the user query, we actually clean that up into a search query. So that's what our first LLM call does, is it cleans it up. So you can see it turns what does a product manager do into product manager job description and responsibilities. And then it uses that to search the search index, the Azure AI search index, and we get back responses, right? So we get back the responses. Each of them has a file name associated with it. Here's the file name, right? And now what we do is then this is the prompt we actually send to the GPT. Let me see if I can I'll go to jsonlint.com, my favorite place for validating JSON, and formatting it. Oh, yeah, actually, that's not that easy to look at. Just trying to find a good place where I can show you this. Here we go. I wanna wrap it. Alright, well, we have the system prompt. The system prompt says all this stuff here, and it includes this thing that says each source has a name followed by a colon. It says use square brackets to reference the source. For example, brackets info one.txt. This part is super key because our RAG applications expects to see the sources as bracket info one.txt so that then it can link the users to those sources. Like I'll show you a deployed version of it so you can give an example what I'm talking about. Because what's turning out is that it just looks like it's basically ignoring that. It's not using the brackets, right? We see it saying according to role library.pdf and according to role library.pdf, but I need the brackets for my front end to figure out what the sources are. Now, I'm sure I could do some prompt engineering or use some other technique in order to figure out the sources, but that's been my observation generally with these local models is that they very rarely pay close attention to my syntax instructions, right? And I don't know why that is exactly. They haven't been trained in like syntactic exactitude. But yeah, so that's really interesting. So I'll show you, let's see, what's the question we asked? So what does a product manager do? Okay. So I'll send this off in this one here. And let me also open the network request so you can see exactly what comes back. Actually, let me change this to not be streaming because it'll be easier to show you the response there. It's a little hard to parse streaming responses in your head. Okay, so here we go. So that's going off to there. Okay, we'll give that a few seconds. This one's actually using GPT-4, and GPT-4 tends to be quite a bit slower. It's using GPT-4 because this one has support for vision, this particular deployment of mine. Usually I use GPT 3.5. All right, so here, notice that we have a citation, and that citation links to the actual PDF. And we really want that, right? Because users need to be able to open the PDF. And the reason we got that citation is if we look at the response, let me see if I can actually find the response in this mess here. So, okay. Let me say, we'll get rid of that. Okay, it's gonna be, oh, no, I didn't I didn't turn off streaming. Oh, no. There we go. Alright. Just gonna do it again just so I can show you. But basically, the response is gonna show it in brackets. I just wanna show you, there we go, okay. So this time, alright, good. So here's the actual content. So if I go all the way to the end of that content, there it is. There's what we wanna see. I'll go ahead and paste that into here. I need to figure out how to word wrap in VS Code. But here, this is what the LLM responded with GPT 3.5 and GPT-4 is the citation in brackets. And that is, to be honest, we use a regular expression to parse it out to be able to display the front end citations. There might be better ways of doing that, but sometimes people got to regex. So that's just my observation is that I have not gotten these local LLMs to successfully produce citations in the right syntax, at least with our current prompt. So clearly, if I really wanted to use one of these, I would need to, do some sort of prompt engineering or something in order to really get it to give the citations in a reliable format, right? Because I don't want to have to, it's not that hard to, use a regex to extract things in brackets, but having to, parse something like according to role library.pdf and across languages and all that stuff, we don't want to do that, right? So we do want them in a consistent format. So if anyone does have familiarity with using these smaller parameter LLMs for more syntactically formatted things, I'd be very interested. Okay, so we have this, and now one final thing that we could try doing to have a couple minutes is that we could actually try evaluating it. So I have this other repo for evaluation. So it's AI RAG chat evaluator. And so I use that to evaluate, different parameters for my for a rag chat application. So what I can do is actually run it against the LLM to see what it thinks. So we'll see if it's working right now. I was making some changes to it earlier today. So we have the config file here. So it has, all right, so I'm going to do, it's going to be a llama 2 is the test. And these are the metrics. So I'm going to ask for groundedness, relevance, coherence, answer length, latency. And then also I have a custom metric, has citation, and that checks to see if it has a citation in brackets. And that's a really important one with these LLMs in particular. Then we have the target URL. So this is going to need to be one of those, Docker URLs again. So going back to the README, I put it in the README because I always forget how to write those Docker URLs. Okay. So let's go back here. Okay. All right, so we're going out to Docker. Let's check the port that we're running on. Is it 505? It is 50505/chat. Okay, so this is the chat endpoint, the one I was just showing in the network console. I usually turn off semantic ranker when I'm running evaluations just because it costs a little more money. And that's part of Azure AI Search. And then I'm going to change the retrieval mode here because remember we had to turn off text. So I'm going to set retrieval mode to text. Okay. All right. And now I'm going to try running that. So let me look at the README to remember how to run. I always document things because I always forget. So first, I'm just going to do a test evaluation just on 2 questions. So I have a bunch of ground truth data, like test data that I test against, which has a question and ideal answer. So it's going to test each of those questions by sending them to this chat application in its current state, and then looking at the answer to see whether the new answer is good. All right. So first, it's sending a test question to the target to ensure it's running. So that should work if we still have this up here. That's still up. Okay. So it got back a response. All right, and then it does a test chat completion to GPT-4 because we're using GPT-4 to actually generate these metrics, and GPT-4 is running. So now it starts the evaluation. So this is where it's actually sending off lots of requests to evaluate the ground truth questions to see what the responses are from the thing. So I can show you like the ground truth is in here. So we have questions. So there's 200 questions here. And then they have truth. And you notice how the truth also has citations in it, since that's part of the truth is where we got the answers from. So it's going to go and send each of those to the current application, which is currently running Ollama 2. Oh, and I just got an error. Oh, wait, let me pull. I just fixed this. Ah, I should have pulled from main. Gonna do it again. Always got to pull from main. All right, sending that evaluation again. While it's running, I'll show you what the current results look like. We'll see if I can do that while it's running in another tab, just so you can see what we're looking for. All right, so review tools. Oh, it doesn't like that I'm doing it. Just let me delete. Okay, let's see. What's the status of that? It's kind of hard to do it while it's doing something, but I think I can just delete this for now. Okay. Okay, good. And then this is still running. All right, good, good, good. Okay, so these are from past runs, just so you can see for comparison what we're looking at here. So you can see like I did do, this is like our baseline. So the baseline is, like we're getting a 98% pass rate for groundedness, 97% relevance, 97% coherence. Those are all GPT metrics where we actually asked GPT-4 to say, hey, how grounded is this? How relevant is this? How coherent is this? Then we also have our custom metrics, like how long was the answer, how many characters long? Because sometimes some prompts will get you really wordy answers, and some of them are like more succinct. And sometimes you want wordy, sometimes you want succinct, sometimes you want just in the middle. We also have whether answer has citation. So we ideally want 100% there. And latency, I've started measuring latency to see how much different parameters might be affect latency. And then, oh, it looks like I've got two different versions of has citation. Okay, I'll have to look into that. I was messing with the wording. All right, and I did do a recent test checking just text retrieval because doing just text and not vector search is definitely going to affect our answers. So I wanted a baseline of doing text retrieval with Azure OpenAI before I compare that to doing text retrieval with Llama 2. Because the fact that we're not using vectors is going to have a huge effect on our search results. And if garbage in, garbage out, if you don't have good search results to pass LLM, you're not going to get, good responses. Okay, so I can show you the results for just two here. So we can see these were, the answers it got from Llama. We've got kind of the summary here. And so now I can actually like open this back up again and look at the Llama one. Pass rate 50%. Oh, it's not doing so good. Not doing so good. And has citation 50%, latency, really slow. Really, really slow. I wonder part of that might be because I think I'm running into am I running the debugger right now for because the debugger is going to be a little slower. So you have to keep in mind if you're running against like your local, yeah, I'm running in debug mode right now in VS Code. So that's going to contribute it. So I'm not going to if I was going to do a true latency experiment, I would need to, make sure I was running not with the debugger for this evaluation. So I'm going to ignore latency for now, but I do think latency is going to be slower with these local LLMs. They're, it's kind of a known thing that they're going to be a bit slow. So yeah, we ran it on 2 questions. It didn't do that well, but we would want to run it on more than that. So ideally, we would just run it on the whole data set. Let's just do it on that feels like a lot because I feel like I already know that it's not going to be as good. So maybe I'll just do it on 50 just to see what it looks like on 50. Because I am spending money, or someone at least, as you're spending money on these GPT-4 calls. So I don't want to unnecessarily waste compute. Okay, so that's going to send that off to those 50 questions and rate the metrics for all of them so that I'll be able to do a comparison against the baseline text retrieval. And then I can also then actually compare answers to each other, right? So let me show this other tool here. So we can do example results, and I want to compare the text retrieval to Llama 2. All right, so what we can see here is that we're actually getting the answers side by side. So I can look at these answers and say, oh, okay. All right, so this is interesting. Like, oh, it's interesting here. Like it's doing this funky syntax, like glossary. So it's like giving the sources. So it just has a very, very different way of citing sources. So I think we really got to figure out how to work with these models to get them to cite sources in a good way. And so we can see yeah, what these ones look like. All right, so there's no citation there, lots of citations there. And then we're still working on the answers to those questions. So there we go. And this is going to take a while, and it's the end of my workday now. So I need to end this stream. But it's really interesting. Now, all my tests were all with, they were all with Llama 2. Not with any of these other models. So, really I need to try out all the other models here and, see what they're all like. Maybe one of them is particularly good for RAG situations. Right now, I haven't found one yet. So far I've only tried Lava 2 with Llama file, and I had the same issue with citations, and then Llama 2 with Ollama. So next one I want to try is Mistral because I've heard such good things about that. But if anyone has any other suggestions for what to try, that'd be really interesting. So there you go. That's Ollama. Pretty cool that you can just have these things on your machine and chat with them really easily and swap out your OpenAI instances with it. And it's really fun to try. So try it out yourself, report back, have fun. Bye, everyone.